So last time we discussed how to find the probabilities underneath the normal curve for three cases. If the point lies in the lower tail, as this one, or upper tail, or between. So we can do the computations for this kind of probabilities. And I think we gave two examples. For example, if we are looking for probability of z smaller than 0.12, and z, as we mentioned last time, is the standardized normal distribution that has mean of 0 and sigma is 1. In this case, just go to the table you have. Now we are looking for 0.12, for example. So here we have 0.1. Under 2, we get this result. This value is the probability of z smaller than 0.12. But we have to keep in mind that we have to transform first from normal distribution to standardized normal distribution. For this specific example, if we are looking for mean of 8 and the standard deviation of 5, that's for the normal distribution. In this case, the z-score is given by this equation, which is x minus mu divided by sigma. So 8.6 minus 8 divided by 5 gives 0.12. In this case, we can use the standardized normal table. Now, for the other case, we are looking for the probability of x greater than 8.6. So we are looking for the upper tail probability. The table we have gives the area to the left side. And we know that the total area underneath the normal curve is 1. So the probability of x greater than 8.6 is the same as 1 minus the probability of x smaller than x less than 8.6. So here, for 8.6, we got z-score to be 0.12. So the probability of z greater than 0.12 is the same as 1 minus b of z is smaller than 0.12. So 1 minus the answer we just got from part A will get this result. So this is the probability of x is greater than 8.6. So all of the time, if you are asking about computing the probability in the upper tail, you have first to find the probability in the lower tail, then subtract that value from 1. So that's the probability for the upper tail. The last one, if we are looking for probability between two values, for example, x, what's the probability of x greater than 8 and smaller than 8.6? So we are looking for this area, the red area. So the probability of x between these two values actually equals the probability of x smaller than 8.6 minus the probability of x smaller than 8. And that, in this case, you have to compute two values of the score. One for the first value, which is 8. This value is 0 because the mean is 0. And we know that z can be negative if x is smaller than mu. Z can be positive if x greater than mu. And equal 0 only if x equal mu. In this case, x equal mu, so z-score is 0. The other one, as we got before, is 0.12. So now, we transform actually the probability of x between 8 and 8.6 to z-score between 0 and 0.12. In this case, we can use the normal table. Now, this area, as we mentioned, is just b of x smaller than 0.12 minus b of x, b of z smaller than 0. This probability, we know that's 0.54878. Now, the probability of z is smaller than 0 is 1/2, because the total area underneath the normal curve is 1, and 0 divided the curve into two equal parts. So the area to the right of 0 is the same as the area to the left of 0. So in this case, minus 0.5. So this is your answer. So the probability of z between 8 and 8.6 is around 0.478. I think we stopped last time at this point. this is another example to compute the probability of x greater than 7.4 and 8. Also, it's the same idea here, just find the z-scores for the two values. Here we end with b of z greater than minus 0.12 up to 0. Now this red area equals the area below 0. I mean b of z smaller than 0 minus the probability of z smaller than minus 0.12. Now, by using symmetric probability of the normal distribution, we know that the probability of z smaller than minus 0.12 equals the probability of z greater than 0.12. Because this area, if we have z smaller than minus 0.12, the area to the left exactly equals the area to the right of the same point because of symmetry. And finally, you will end with this result. Or b of z minus 0.12 all the way up to 0, this area is the same as the area from 0 up to 0.12. So this area actually is the same as b of z between 0 and 0.12. So if you have negative sign, then take the opposite one. The answer will be the same because the normal distribution is symmetric around the 0 line. The questions? I think we stopped here. And also we talked about empirical rules. The one we mentioned in chapter 3. And we know that, as we mentioned before, that is 68.26% of the observations fall within one standard deviation of around the mean. So this area from mu minus 1 sigma up to mu plus sigma, this area covers around 68%. Also, 95%, or actually 95.44% of the data falls within two standard deviations of the mean. And finally, around most of the data, around 99.73% of the data falls within three standard deviations of the population mean. And now the new topic is how can we find the x value if the probability is given. It's vice versa. In the previous questions we were asking about find the probability, for example, if x is smaller than a certain number. Now suppose this probability is given and we are looking to find this value. I mean, for example, suppose in the previous examples here, suppose we know this probability. So the probability is given. The question is, how can we find this value? So it's the opposite. Sometimes called backward normal calculations. There are actually two steps to find the x value for a certain probability, or for a given, or for a known probability. In the first step, we have to find the z-score, then use this equation to find the x value corresponding to z-score you have. And x is just mu plus sigma times mu. So first step, we have to find z-score corresponding to the probability we have. So find the z-value for the known probability. Then use that z-score to find the value of x by using this equation. So x equals mu plus z sigma. Z could be negative, could be positive, depends on the probability you have. If the probability is above 0.5, I mean 0.5 and greater than 0.5, z-score is positive. But if z-score is negative, I'm sorry, if the score is negative, then the probability should be smaller than 0.5. So if the probability is given less than 0.5, then your z-score should be negative. Otherwise, it should be positive. So you have to be careful in this case. Now look at this example. Let x represent the time it takes in seconds to download an image file from the internet. The same example as we did before. And here we assume that x is normal distribution with mean of 8 and standard deviation of 5. Now, let's see how can we find the value of x such that 20% of download times are smaller than x. So this probability is a fraction. Also, always the probability is between 0 and 1. So the probability here is 20%. In this case, your z-score should be negative because 20% is smaller than 0.5. So z-score should be in this side, in the left side. So here again, he asks about find x value such that 20% download time are smaller or less than x. So here again, we are looking for this value, or the value of x, which is smaller than the area to the left of this x equals 0.2. Now, the first step, we have to find the z-score. It's backward. Z-score first, then x. Find the z-score corresponding to the probability of 0.2. The approximate one, the near value, I mean, to the 0.2 is 0.2005. Sometimes you have the exact value from the table you have, but most of the time you don't have. So we have to look at the approximate value, which is very close to the one you have. So here we are looking for 0.2. The closest value to 0.2 is 0.2005. Now, the corresponding value to this probability is minus 0.8 all the way up to 4. So your z-score is negative 0.84. So this is the first step. Any question? Again, now if we just go back to this equation, z equal x minus mu over sigma, the cross multiplication, I mean, if you multiply both sides by sigma, you will get sigma times z equal x minus mu. So x equal mu plus this. So this is the equation. X equal mu plus and z sigma. Now, in this question, he asks about find the value of x such that 20% of download times are less than x. Now, the probability is less than 0.5, so your z-score should be in the left side. So here we need to find the value of z first. Go back to the normal table you have. This is the normal table. We are looking for minus 0.2. I'm sorry, we are looking for 0.2. So the closest value to 0.2 is this one, 0.2005. So this is the closest value. So the exact answer sometimes not given. So the approximate one minus 0.8 all the way up to 4. So this score minus 0.8. Any question? So the value of this score is minus 0.84. So my corresponding x value equals to x equal mu. The mu is given as 8 plus z is minus 0.84 times sigma. Sigma is 5. You will end with 3.8. So this means the probability of x less than 3.8 exactly equal 0.2. So in this case the probability is given, which is 0.20, and he asked about what's the value of x in this case. So the first step was finding the score, then use this value, plug this value, yes, to find the corresponding x score. And that's the backward normal calculations. Let's do one problem from the practice, which is number 18. مش تعلم. Is it clear? The owner of a fish market determined that the average weight for a catfish is 3.2. So this is the value of the mean. هذا بس هذا مش وورد، هذا بار. So again, the owner of a fish market determined that the average weight for a catfish is 3.2 pounds. So the mean is 3.2 with a standard deviation of 0.8. So sigma is 0.8. Now, assuming the weights of catfish are normally distributed, in this case, he asks about what's the probability that a randomly selected catfish will weigh more than 4.4. So, what's the probability of x more than, so greater than 4.4? I just gave the idea to solve this problem. At home you can complete to find the exact answer. So first step, find the score. Z is 4.4. Divide by 6. Just compute this value. It's 0.8. Divide by 0.8 equals 1. So Z score is 1. So we are looking for the probability of Z greater than 1. 1.2? 1.5. So we are looking for the probability of X of Z greater than 1.5. Which is 1 minus B of Z less than 1. Now go back to the table. Now 1.5 under 0. It's 0.9332. 1 minus this probability gives 0.668. That's the probability of x greater than 4.4. So the answer is 0.0668. Now for the same question, what's the probability that a randomly selected fish will weigh between 3 and 5 pounds? 3 up to 5. So first step we have to find the score for 3 or 5. For 3 is just 3 minus 3.2 divided by 0.8 is the first z-value. Negative 0.2 divided by 0.8 minus 0.25. The other one, 5 minus 3.2 divided by 0.8, 1 minus 0.8 divided by 0.8 equals 2.25. Just double check this result. So here the probability of x between 3 and 5 equals minus 0.25, smaller than z, smaller than 2.5. So it's transformed from normal distribution to standardized normal distribution. So here instead of computing the probability of x between 3 and 5, we are looking for the probability between z between actually minus. It's minus because your value here is smaller than the average. The average was 3.2, so it should be negative. So this score between minus 0.25 all the way up to 2.15. So now, this is the probability we are looking for. 0 in the middle, minus 1/4 to the left of z, of 0, mu of 0, and this is the value of 2.25. Now we are looking actually for this probability. The area between minus 0.25 all the way up to 2.25. So this area equals a probability of z less than 2.25 minus and again use the normal table to give this value and the other value. Any question? So first step here, we compute the z-score for each value of x. So the problem is transformed from normal distribution to standardized normal distribution. So it becomes z between minus 0.25 up to 2.25. Now this area, this dashed area, equals the area below 2.25 minus the area below minus 1.5. Now, by using the similar way we did before, you may compute the value of z, the probability of z is more than 2.25 by using the normal table. So here, 2.2 up to 5. So 9878. 9878. So the area below 2.25, 2.2 this value, all the way up to 5 gives 9878. Now, what's about the probability of z smaller than minus 0.25? if you go back to the Z table, but for the other one, the negative one, minus 0.2 up to 5, 0.4013 minus, that will give the probability between 3 and 5. This is the second part. So the final answer, 5865. So this is the probability that the selected catch fish will weigh between 3 and 5 pounds. Now, other question is, for the same problem, you said a citation catfish should be one of the top 2% in the weight. Assuming the weights of catfish are normally distributed, at what weight in pounds should the citation limitation be established? So in this board, he asked about what's the value of x, for example, greater than what value here, and this probability equals 2%. Because he said the citation catfish should be one of the top 2%. So the area on the right here, this area is 2%. What's the value of x in this case? So here, probability of x greater than a equals 0.02, and we are looking for this value. The table gives the area to the left side. So this probability actually, the area to the right is 2%, so the area to the left is 98%. So this is the same as we know, the equal sign does not matter because we have continuous distribution. Normal is a type of continuous distribution, so equal sign does not matter. So now, if you ask about P of x greater than a certain value equals a probability of, for example, 0.02, you have to find the probability to the left, which is 0.98, because our table gives the area to the left. Now, we have to find the value of A such that the probability of x more than or equal 0.98. So again, we have to look at the normal table, but backward, because this value is given. If the probability is given, we have to look inside the body of the table in order to find the z-score. Then we can use x equal mu plus z sigma in order to find the corresponding value of x. So again, go back to the normal table, and we are looking for 98%. The closest value to 98, look here, if you stop here at 2, you go to the right. Here we have 9798 or 9803. So the answer might be, your z-score could be 2.05 or 2.06. So again, in this case, the table does not give the exact. So the approximate one might be between them exactly, or just take one of these. So either you can take 9798, which is closer to 98% than 9803, because this is 3 distant apart. So maybe we can take this value. Again, if you take the other one, you will be okay. So you take either 2.05 or 2.06. So let's take the first value, for example. So my x equal mu z is 2.05 times sigma 0.8. Multiply 2.05 by 8.8, then add 3.2. You will get, what's your answer? 3.2 plus 2. So around 4.8. So your answer is 4.84. Now if you go back to the problem and suppose you know the value of x. So the probability of x double check to the answer. $4.84. Just check. B of x greater than this value should be 2%. So the probability of x greater than this value should be equals 0.02. So this problem is called backward normal calculation, because here first step we find the value of the score corresponding to this probability. Be careful. The probability of x greater than 2 is 0.02. So my value here should be to the right, because it says greater than a is just 2%. If you switch the position of a, for example, if a in this side, and he asks about b of x greater than is 2%, this area is not 2%. From a to up to infinity here, this area is not 2%, because at least greater than 0.5. Makes sense? So your a should be to the right side, because the probability of x greater than a 2% is on the other side. Let's move to the next one. For the same question. Again, the owner of catfish market determined the average weight of a catfish at 3.2 with standard deviation 0.8, and we are assuming the weights of catfish are normally distributed. He asked about above what weight do 89.80% of the weights occur? Above, so x greater than.
X minus.
89. So this is the percentage he's looking for. 89.8%. Now what's the value of A? Or above what weight do 89.8% of the weights occur? Just make the normal curve in order to understand the probability. Now, A should be to the right or to the left side?
Left.
Imagine A in the right side here. Do you think the area above A is 89%? It's smaller than 0.5 for sure. So it should be the other side. So this is your A. Now this area makes sense that it's above 0.5. It's 0.8980. Now B of x greater than A equals this value. And again the table gives the area to the left. So this is actually x less than A. 1 minus this value equal 0.1020. Now go back to the normal table. Here it's 0.102. So A should be negative. I mean your z-score should be negative. Now look at 0.102. Exactly this value. 0.102. It's minus 1.2 up to 7. So minus 1.27. Minus 1.2 all the way up to 7 is 0.102. So the corresponding z-score is minus 1.27. Now x again equals mu plus d sigma. Mu is 3.2 plus z is negative 1.17 times sigma is 8. So it's equal to 3.2 minus 127 times 0.8. By calculator you'll get the final result. If the probability is smaller than 0.5, then this score is negative. So go to the other one. If the probability is above 0.5, then use the positive z-score. So what's the answer? 2.18. Be careful. In the previous one, we had a probability of x greater than A equal 2%. In this case, the value of A, for example, is located in the upper tail here. For this part, he asked about B of x greater than equal 0.89. It's 0 more than 0.5 should be in the other side. So here B of x greater than equal this value, which is the score in this case minus 1.17. So the corresponding A score actually is 2.184. So this is the weight that 89.8% of the weights are above it. So around 90% of the catchfish have weights above this value. So around 2 pounds. So around 90% of the weights are above 2.18 pounds. Maybe this is one of the most important questions in this chapter. Any question? The last part here for the same problem, he asked about what's the probability that a randomly selected fish will weigh less than 2.2 pounds? I think straightforward.
Yes, sir.
We did similar in part A. So B of X less than 0.2. So he's looking for this probability, which is straightforward one. This score 3.2 minus, I'm sorry, it's 2.2 minus, it's 2.2 minus 3.2 divided by sigma. So minus 1 divided by 0.8. 1.25. 1.15. So 1 over minus. So again, find the probability now of z less than negative 1.25. Now in this case we have to use the negative z. It's negative 1.15 minus 1.2 up to 5. So 0.1056. So the answer is around 10% of the catfish will weigh less than 2.2 pounds. So the answer is 0.1056. Questions? So go back to the PowerPoint presentation. We have the last topic, evaluating normality. Many times we mention something about normality and outliers. For sure, if outliers exist, in this case, the distribution is not normal. Now, how can we tell if data point is an outlier? If you remember, we talked about outlier in chapter 3 by two ways. By this score and we mentioned that any data point below minus 3, I mean smaller than minus 3, or above 3, these points are suspected to be outliers. So any point, any data value smaller than minus 3 in this score, or above plus 3 is considered to be an outlier. Or if we compute the lower limit, which is Q1
minus 1.5
IQR, or the upper limit,
Q3 plus 1.5 IQR.
So we have lower limit, upper limit. So lower limit and upper limit. Any data point below lower limit or above upper limit is considered to be an outlier. So therefore we have two methods to determine or to examine if the observation is an outlier or not. One by using this score, straightforward, and the other one we have to look for the lower limit and upper limit. The other method by using software, and later on you will take SPSS in order to determine if the data is normally distributed by using something called a QQ plot or normal probability plot. So I'm going to skip this part because it's better to take it by using software. But in general, you may look at this graph Generally speaking, if you have a probability plot of a data and the points lie on straight line or close to it, in this case the distribution is normal. It's hard to make this graph manually. It's better to use software. But at least if we have this graph and the points are close to the straight line, I mean the points are either on the straight line, lies on the straight line, or close it. In this case, the data is normally distributed. Otherwise, if the data points scattered away of the straight line, then the distribution is not normal, either skewed to the right or skewed to the left. So for this specific graph, the plot is normally distributed, approximately normally distributed, because most of the points here lie close to the line and few are scattered away. Or it means that there are few outliers in this case. We can ignore these values. So here plot is approximately a straight line, except for a few outliers at the low and the right, those points. So generally speaking, the distribution is normally distributed. That's all for this chapter.